All right, I wanted to give you a little bit of info on the exam. So exam number 2, the average was quite high actually. The average was 87 and the high score was 100. So I don't know if there's really any problem that I feel like I need to comment on specifically. I think if you have any specific questions on your exam, feel free to talk to me after class, and I'd be happy to answer any of those questions about how yours was graded. Or if you want to know what the answer was to a specific problem, I would be happy to tell you. Okay, so let's get started with section 4.1 homework on Maxima and Minima. Any homework questions I can answer? Yeah.
Number
33. Right. So 33, we have f of x equals e to the x plus e to the minus x over 2, and we want to find the critical points. Okay. So 33, we have f of x is equal to e to the x plus e to the minus x divided by 2. And we want to find all the critical points. Okay. So first thing we need to do is we want to take a derivative, set it equal to 0, and hopefully solve for x, right? So if I take a derivative of this function, by the way, this could be written as e to the x over 2 plus e to the minus x over 2 if we would like. It might make our lives easier in some sense as we take the derivative. So f prime of x is equal to the derivative of e to the x over 2. The 1/2 just stays, and the derivative of e to the x is e to the x. So it's just e to the x over 2. And then the derivative of e to the minus x over 2 is the e to the x will produce a -1 when we take the derivative of negative x. So I get minus e to the negative x over 2. Okay, and so to find critical values, I'd like to set that thing equal to 0 and solve for x, correct? So if I set this equal to 0, then I get that e to the x over 2 is equal to e to the minus x over 2. Of course, if I wanted to, I could just multiply both sides by 2. So I get that e to the x is equal to e to the minus x. Now, one thing that I could do at this point is I could just take the natural log of both sides of the equation. And if I take natural log of both sides, I get ln of e to the x is equal to ln of e to the minus x, or another way of saying that is x equals minus x. And the only way that that's true, right, is where? Is if x is 0, right? Or I could just, if you don't like that, I could add an x to both sides and say that 2x equals 0, right? So x equals 0, that also works. So we get that we have one critical point for this function, and that is at x is equal to 0. It's our one critical value. And I believe that's all they were asking.
Because we're not given an interval, we don't plug anything else into the original equation.
What's that?
Because we're not given an interval between this and this, we don't plug anything into the beginning equation.
Right. All they're asking for right now is just what is the critical point in this problem. Some other problems, they might ask something else. Other questions? Yeah.
39.
39, okay. Let's see. We have f of x equals x times the square root of x minus a. Again, we're just trying to find the critical values. Okay. X square root x minus a. So 39, we have f of x is equal to x square root x minus a. Okay, so again, to find critical values, I want to take a derivative, set it equal to 0, solve for x, right? So we want to find a derivative. So this is a product, so I need to use the product rule. So I get the first, which is x, times the derivative of the second. Well, the derivative of x minus a to the 1/2 would be 1/2 times x minus a to the negative 1/2 times the derivative of what's inside, which is just 1 in this case, plus the second, which is x minus a to the 1/2 times the derivative of the first one, which is just 1. Okay, so here's our derivative. Now I'd like to set this equal to 0 and solve for x. So if I set that equal to 0, oh wait, I made a mistake somewhere. I didn't take a derivative of the inside. Oh yeah, I did, because the a is constant, so I think everything is fine. Okay, so I want to solve this thing. So there's a couple ways that I could go about this. I think one of the things I want to do is I do want to put this thing on the bottom. I think it's going to make my life easier. So let's rewrite before I start. So this is actually an x on top, and on the bottom I have a 2, and I have a square root of x minus a on the bottom. Then this one, I just have the square root of x minus a, and that's equal to 0. So now I could move one of these guys to the other side. So maybe I could write it as x over 2 square root of x minus a. I could say that that's equal to negative square root of x minus a. And now I could, so to speak, cross multiply. This is over 1. So I can move that up here, multiply 1 over here, and I get x on one side. And on the other side, I get is equal to negative, there's a 2, and then I multiply the square root of x minus a times the square root of x minus a, which just gives me x minus a. And I still need to solve for x, so I get x is equal to negative 2x plus 2a, or I get to add 2x to both sides, and I get 3x is equal to 2a. And finally, I get that x is equal to 2/3 a. And that would be the one critical value in this case. Yeah.
Is there also a critical point at a, because if you put in a at the bottom, doesn't it give division by 0?
Oh, so yeah, good question. So the question is A itself a critical point? Let me think about that for just 1 second. So when I take the derivative, I get this guy, right? And so the question is A, if I plugged in A, do I get division by 0? And that's equal to this. And I do get division by 0. So we could, let me look at this original function. So A. Yeah, it certainly doesn't hurt to include division by 0. So, and we should. So including x equals a, I'm looking at this original function and trying to decide, do I actually think that this is going to be a max or min? But I guess I don't care. is it a critical point, right? So yes, it is. Because it gives division by 0 in the derivative. Yeah.
Are we assuming that A is not 0?
Oh, maybe we are. Let me see, what are we saying? Assume that A is a non-zero constant. Yeah, but that's okay. We can still say that x equals A is a critical point. We're just saying that A itself isn't 0. So yeah, everything's fine. Yes, sir.
We do 59.
59, sure. 59, okay. We get f of x is equal to 4x cubed over 3 plus 5. Okay, and what do we want to do? Determine location and value of absolute extreme values of f on the interval if they exist. Okay, so when we're trying to find absolute extrema or absolute max and min, where can they happen? Yeah, that's right. Either you're going to have your absolute max and min at an endpoint, or you're going to have your absolute max and min at a critical value. So in this problem, what we want to do is we want to say, okay, first of all, just what are the critical values? Then once we've found the critical values, test the original at the endpoints and the critical values in the original function, and just see which one's the biggest and which one's the smallest. So that's the general strategy. Okay, what number was it? I'm sorry, 59. Okay, let's take a look at 59. So we have f of x is equal to 4x cubed plus 5x squared minus 6x. This is 4/3 x cubed plus 5x squared minus 6x on the interval from -4 to 1. Okay, so we want to find the absolute max and min. So like I said, the way that we go about finding absolute max and min is, first of all, what are the critical values? And more specifically, what are the critical values that are in my interval? If there's a critical value that's not in my interval, I don't care, because I'm just trying to find the absolute max and min over that interval. So let's take a derivative, and I get, this would be 4x squared plus 10x minus 6. And now there is no division by 0 here, so all I have to do is set that equal to 0 and solve for x. Okay, so it would be really nice if that factored. Does it?
Yes.
Okay, what's it factored to?
You can pull the 2 to the outside, and then it goes x plus 3, 2x minus 1.
Okay, so you said x plus 3, 2x minus 1 after you factored out a 2.
Yeah.
Okay, let's just make sure. So I get 2 times x times 2x, which is 4x squared. Then I get what? How many x's do I get? I get 2x times minus 1, which is minus 2 of them. And then I get 3 times 2 is 6, times 2 is 12, plus 12 of them is 10. And then finally I get 2 times 3 times minus 1. It's minus 6. That looks perfect. Okay, so that factors, and that is equal to 0. And so that would be true if x is equal to -3, or x is equal to positive 1/2. And then the question is, are either of these actually in my interval? And in this case, both of them are in the interval, correct? Okay, so since both are in the interval, that means that I'm going to have 4 different places that I need to test back into my original function. I need to test the left endpoint, the right endpoint, and the 2 critical values. back into the original function to see which one's gonna give me the biggest value and which one's gonna give me the smallest value. So what do we need to do? So we need to find what is f of minus 4. What is f of minus 3? What's f of 1/2? And what is f of 1? And then whatever comes out being the biggest number is my absolute maximum. Whatever's my smallest number is my absolute minimum. So if we plug in minus 4, let's say, then I get 4/3 times minus 4 cubed plus 5 times minus 4 squared, and then minus 6 times minus 4. Okay, what do we have here? So minus 4 cubed is what? Or does somebody just have this?
-64.
This, yeah, so minus 4 cubed is negative 64 times 4 is what? What's that?
-256.
Negative 256. Okay, negative 256 over 3. And then I get, if I square this, this is 16 times 5 would be 80. Does that sound correct? And then finally I get negative 6 times negative 4, which is 24. Okay,
The whole thing should be 56 over 3.
what's that?
The whole thing should be 56 over 3.
Oh, at the end?
Yeah.
Oh, thank you. 56 thirds. Okay, thank you. Okay, so if I plug in minus 3, we get 4/3 minus 3 cubed plus 5 minus 3 squared minus 6 times minus 3 is equal to minus 3 cubed is negative 27 divided by 3, negative 9 times 4, negative 36. Okay, negative 3 squared is 9 times 5, 45. And then negative 6 times negative 3 is 18. So what do we get? So 45, 50, 63 minus 36 is what? 27?
Yes.
Okay, 1/2. Get 4/3 times 1/2, quantity cubed plus 5 times 1/2 squared minus 6 times half. Okay, that's 1/8 time 4 over 8 is just a half, right? So a half times a third is a 1/6. Okay, and then we get 5 over 4. And then we get minus 3. Somebody have a nice version of that?
Negative 19 over 12.
Negative 19/12. Thank you. And then finally 1 4/3 times 1 cubed plus 5 times 1 squared minus 6 times 1 is equal to, what's that?
1/3.
1/3. Okay, so now the question is which of these things is the biggest and which of these things is the smallest? I think that the smallest is fairly obvious because there's only one of them that is negative. So this guy is the smallest value. And then the biggest value, well, certainly 1/3 is smaller than 27. What about this guy? Well, that's less than 20, right? So this guy's the biggest. So this is my max, and this is my min, but we should write it well. And I think that we need to get into the habit of writing maxes and mins well, because there's really two things going on, right? There is the absolute maximum value, which in this case is 27, and there's the value at which I obtain the maximum value, which is -3. So I like to just write it all out so I can't be wrong. Okay, so when I get an answer like this, I usually write F as an absolute maximum of 27 at x is equal to -3. And then I'll say F as an absolute minimum of -19/12 at x is equal to 1/2. And now I'm done. And the reason that I write it this way is sometimes questions are asking you for the x value. Sometimes questions are asking you for the y value. But if you write it out like this, you are never wrong, right? You've never left out the important information. So I think that this is a good way to end like a max min type problem, because you just know you can't be wrong. Yeah.
Could you write it as like coordinates?
That's what I want to be careful of, just writing a coordinate, because then that makes the reader interpret, well, which of those is, like, let's say that I asked you on this question, which I suppose I did, what's the absolute maximum? And you wrote the absolute maximum is 327, -327. I'm like, so is it -3 or is it 27? Which one of those two values is the absolute maximum? Well, it's the y value, but I think it's just better to like spell it out for the reader. It's like the absolute maximum is this, that happens at this x value. Yeah. Other questions? Yeah.
Could you do number 53?
53. Okay, so 53, we've got 2x to the x. Okay. So 2x to the x, and again, we're trying to find absolute extreme on 0.1 to 1. Okay. F of x is 2x to the x. And the interval is 0.1 to 1. So this is from 0.1 to 1. Okay, so we have something with x's in it raised to an x power. How should we go about taking this thing's derivative? Yeah, so we could take the natural log of it, or we could write it as like e to the ln of this thing, and then bring the x down. There's a couple different ways to do it. Let's go with this one this time, just because. Okay, so I'll write f of x is equal to e to the natural log of 2x to the x, which is certainly true. But here, now by the power rule for natural log, I can take that x out in front of the ln. So I could write this as e to the x ln of 2x. And now I've got e to a power. So I know how to take the derivative of e to a power. So the derivative f prime of x should be equal to, well, you just write the same thing again. So it's e to the x ln of 2x times the derivative of the exponent. but the exponent is a product. So we should use the product rule. So I take the first guy and leave it alone, times the derivative of ln of 2x. What is the derivative of ln of 2x? Yeah, 1 over 2x times 2 by the chain rule. So it just ends up being 1 over x. So times 1 over x plus the second, which is ln of 2x, times the derivative of x, which is just 1. Okay, so this is it. Let's rewrite that. So e to the x ln 2x, that's otherwise known as this guy, which is otherwise known as this guy. Right, that's just 2x to the x is sitting right here. So I don't know if it's better to write it that way or not right now, but I will. And I can always change it back later if I don't like it. So this is 2x to the x. This is a 1. And then I've got plus ln of 2x. And now the question is, can that be set equal to 0 and solved for x? So this guy, I'd like to say, you have 2x to the x times 1 plus ln of 2x. What if I set that equal to 0? Okay, I have a product of two things that's equal to 0, correct? So that means that one of those two things would have to be equal to 0. So I can think either this is 0 or this is 0, correct? Now, what do you know about natural log? Is it can be negative, right? It's negative between 0 and 1. So it is possible that this thing could be 0 in this interval. But what about this one? So in this interval, is this thing ever going to be 0? Well, if I plug in a positive value here and a positive value here, I'm certainly not going to get any zeros. Does everybody agree? So this is never 0. This might be 0. So now I just need to say, is 1 plus ln of 2x, is that ever 0? Which would mean that ln of 2x would have to be negative 1, which would mean that if I raise both sides to like e to this power is equal to e to this power, then I'd have e to the ln of 2x is equal to e to the minus 1, or 2x is equal to e to the minus 1, or x would be equal to, I suppose I divide both sides by 2, and I get that this is 1 over 2e. And so the question now is that number, what is this number? If you plugged it into your calculator, what would you get?
0.184.
Okay, so this is like 0.184 something. That's bigger than 0.1. So it is actually a critical value that I'm concerned with. So my one critical value would be 1 over 2e. Okay, so now if I want to find the absolute max and the absolute min, I need to plug the endpoints into the original function, and I need to plug any critical values into the original function. My only critical value in this case is 1 over 2e. So, back over here. And I need to find what is f of, and notice I'm using the original function here, not the derivative. That's important. because you're trying to see where is the function big or small, not where is the derivative big or small. So I need f of 0.1. I need f of 1 over 2e. And I need f of 1. So in this function, f of 0.1 is 2 times 0.1 to the power 0.1. This one would be 2 times 1 over 2e to the power 1 over 2e. And then finally I get, this is 2 times 1 to the power 1. This one I can do, it's 2. The other ones are a little harder to do it in your head. What do they come out to, if anybody has them?
0.1 comes up to 1.59,
This is 1.59,
and then the 1 over 2e comes up somewhere around 1.46, I believe.
1.46. So we could say that this guy is the smallest one. This guy is the biggest one.
I got very different values.
Oh, okay. Well, it happens.
I have 0.851.
Yeah.
Okay, so for which one?
For 0.1, I have 0.851.
0.851.
And then the other one is 0.832.
This is 0.832. Okay. Well, I could plug it in yourself to your calculator. Make sure you fit. In this case, though, this is different. This is the max. Oh, I suppose this is still the min, right? So at least we agreed on that. So this is our minimum value. It's our max value. Did you get the other one? Are you trying?
Trying to figure out my code.
No problem. So anyway, so I would say F has an absolute maximum of 2 at x equals 1. And F has an absolute minimum of, in this case, at least providing calculator correctness, 0.832. I assume that that's not the exact value, probably.
Correct.
Approximately 0.832 at x is equal to 1 over 2e. And we're done. Let's see. Okay. Any other questions? Yeah.
Can we do 63?
63. Sure. So we have f of x equals secant of x on an interval, and what are we doing on this one? Okay, so we're still determining absolute max or absolute min. Okay, so f of x equals secant of x on that interval. So 63. Secant of x on, okay, good. All right. So similar thing, take a derivative, find all the critical points, and then test the critical points and the endpoints into the original function. So we've got f prime of x. What's the derivative of secant of x? Yes, secant of x, tangent of x. So this is secant x times tangent x, and we'd like to know where is that equal to 0 or undefined, I suppose. on this particular interval. So maybe we should rewrite this a little bit just to see what we're dealing with. Secant is 1 over cosine of x, and tangent is sine of x over cosine of x. So I suppose that if sine is 0, that's a critical value, because that would make the whole thing 0. And if cosine is 0, it would cause division by 0. So is there anywhere in this interval where either of those things happens? Where is sine 0?
So, 0.
At angle 0, right? And then it is again at pi. But pi is too big, so we don't care about pi. It's not in the interval. So 0 is definitely a critical value. So if I'm finding my critical values, I've got x is equal to 0. And then what about cosine? What's the first time that cosine is 0? Pi over 2. But pi over 2 is too big, right? And it's also 0 at negative pi over 2, but negative pi over 2 is too small. So this is the only critical value that I need to worry about, because it's the only one that actually falls into my interval. And so I need to test my critical value, 0, and my 2 endpoints in the original function. Okay, so I want to find what's f of negative pi over 4. I need f of my critical value 0, and then I need f of pi over 4. And remember, secant of x is 1 over cosine of x. So I could write that this is secant of negative pi over 4. Or if you would like, this is 1 over cosine of negative pi over 4. And f of 0 is just secant of 0, or if you like, 1 over cosine of 0. And then f of pi over 4 is secant pi over 4, or if you like, 1 over cosine of pi over 4. Okay, so then the question is, what are all those? So what is cosine of negative pi over 4? Remember our little A smart trig class. This is where the trig functions are positive. Cosine is positive in the 4th quadrant. So cosine of negative pi over 4, which is this angle, is positive. And what is its value? Yeah, square root 2 over 2. So this is 1 over square root of 2 over 2. Or if you prefer, that would be 2 over square root of 2. But that's also known as the square root of 2. Correct? What's cosine of 0? 1. Yeah, so this is just 1 over 1, or 1. And then finally, what do we get on this guy? Cosine of pi over 4 again, it's positive. And so it's square root of 2 over 2. So this is just 1 over square root 2 over 2. Again, that's 2 over root 2, or root 2. And notice these are the same, but it's okay. You can have more than one absolute max or absolute min. Which is bigger, the square root of 2 or 1? Square root of 2 is bigger than 1. Yeah, so these two are my absolute max. And this one is my absolute min. So this is the min, this is the max, this is the max. But I would write it out. So f has an absolute maximum of square root 2 at x is equal to, let's see, negative pi over 4 and at x is equal to pi over 4. And then f as an absolute minimum of, I suppose, 1 at x is equal to 0. That's it. Sound good? Okay, that should definitely give you a good push in the right direction on this assignment. So this one's due today. As soon as I get back to my office, I'll be putting homework up over the next section over 4.2, which is, the mean value theorem stuff. So, question.
Can we get new answer key, because the last one was just for 3.
Oh yeah, I can send out some answers to problems if you would like. Yeah, for sure. Okay, have a good day. I will see you on Friday.